Let's start our lecture. Let me share my screen with you. I hope you all of you can see my screen. If you can remember, last week we started our second chapter, basic concepts of probability, and there we discussed some types of events and how to list all the possible outcomes for an experiment, and we discussed how to draw Venn diagrams if we have two or more events. Okay, I taught you how to give a graphical representation of two events with so that they are intersecting. Like that, we discussed some concepts used in probability, right? Today we have to discuss about tree diagrams. I know you already know how to draw a tree diagram for a particular situation. Anyway, in this section, we will look at more examples of probability and we will use tree diagrams to solve those problems. Okay, first look at the example number 1. Right. Read the question very carefully. Right. Box A contains 3 cards numbered 1, 2, 3, and box B contains 2 cards numbered 1 and 2. One card is taken at random from each box. Now we have a probability problem. Okay, we have some questions to be answered. Before that, we have to draw a tree diagram to list all the possible outcomes. Actually, if we have, when we have this type of question, we don't need to draw a tree diagram if the question does not ask it. Right here, in the first part, draw a tree diagram to list all the possible outcomes. Here we are asked to draw a tree diagram. Without drawing a tree diagram, we can answer for these questions. But here we have to draw a tree diagram to represent or list all the possible outcomes for this problem. Okay, so read the question again. Box A contains 3 cards numbered from 1 to 3. And there's another box, that is box B, and it contains 2 cards numbered from 1 to 2. Right, now we have 2 boxes. Now it says 1 card is taken at random from each box. Now we are taking only 1 card from 1 box, right? Now, can you draw a tree diagram to indicate the associated probabilities? Can you draw for this situation? After drawing a tree diagram, we have to answer these questions. We need to find the probability that the sum of the numbers is 4, sum of the 2 numbers is even, the product of the 2 numbers is at least 5, the sum is equal to the product. So first of all, we need to draw a tree diagram. Then we will be able to answer these questions by looking at the tree diagram, right? So let's draw a tree diagram for that situation. We have only 2 boxes, box A and box B. Right, box A contains 3 cards numbered from 1 to 3, and box B contains 2 cards from 1 to 2. Altogether, there are 5 numbers. Okay, only 1 card is taken at random. So when we draw this, draw a tree diagram to indicate this probability, right? We need to consider these boxes separately. Okay, here I am showing you the particular tree diagram for this situation. Now don't look at the right side of the diagram, right? Only look at the tree diagram. Here, first we have drawn these branches for the outcome of box B. If we select one card from box A, right, how many possible outcomes are there? It has only 3 cards, no? From number 1 to 3. Therefore, we may get either 1, 2, or 3 from box A. Now we finished drawing the outcomes of box A. Then we need to draw these branches for the outcome of box B. So if we select one card from box B, how many possible outcomes are there? Box B contains only 2 cards, right? It contains only 2 cards. Therefore, we may get either 1 or 2 from box B, right? Let's say the card drawn from box A is 1. Then what can be the second outcome, or what can be the card selected from box B? It may be either 1 or 2. Likewise, if we get number 2 from box A, what are the possible outcomes for box B? We may get either 1 or 2. Likewise, if we get number 3 from box A, again we may get number 1 or 2 from box B as well. Understand? So box A contains 3 cards, therefore it has 3 possible outcomes. Box B contains 2 cards now. Therefore, we have 2 possible outcomes. Altogether, we will have 3 times 2, 6 pairs. 6 pairs. Okay, so this is the outcomes. These are the outcomes of the experiment. Now we are taking 2 cards from 2 boxes, 1 card from 1 box. Okay, so the outcomes are 1, 1. We may get either 1, 1 pair or 1, 2, 2, 1, 2, 2, 3, 1, 3, 2. Likewise, we have 6 pairs. Okay. Actually, when we draw a tree diagram, it's required to indicate associated probabilities of each events. Understand? Here in this tree diagram, I have not shown them, but you have to write each and every, you have to write associated probabilities on each and every branch. Okay, then only it will be completed. Otherwise, it's an incomplete tree diagram, right? So when you draw a tree diagram, please put all the associated probabilities on these branches. Okay, right? Say, give me a second. I will show you how to put those probabilities, right? Okay. Now box A contains 3 cards. Therefore, we have 3 possible outcomes. Now tell me, what is the probability of getting number 1 from box A? It has only 3 cards now. Without looking at the box A, we are taking 1 card. Therefore, probability of getting 1 is 1 upon 3. You should put this probability on this branch. Okay. Then probability of getting 2 is again 1 upon 3, because 3 cards, out of 3 cards, we are taking only 1. Likewise, probability of getting number 3 is again 1 over 3, right? Now let's move on to the next branch or next box, right? Or the next part of the experiment, that is taking a card from box B. Right? Now box B contains only 2 cards from number 1 to number 2. Out of 2 cards, we may get either 1 or 2. 1 or 2. 1 or 2. So this is the outcome for box B, right? Now what is the probability of getting number 1 from box B. Now forget about the outcome of box B, right? Forget this. Getting number 1 from box B does not depend on the outcome of the box A. Understand? Because there are 2 boxes. Those 2 boxes contains those cards separately. So the outcome of the box B does not depend on the outcome of the whatever the outcome from box A. It does not depend. Understand? Therefore, probability of getting number 1 from box B is what? 1 upon 2. Out of 2 cards, they are taking only 1. Here also 1 over 2. Understand? Likewise, we can put all the probabilities in the tree diagram like this. These probabilities do not depend on the probability of getting number 1 or 2 or 3 from box A. Okay, that's what you should understand when you draw a tree diagram. Okay, now you can write, or you can list all the possible outcomes in this for this experiment. So we write those outcomes as pairs. Okay, 1, 1, 1, 2, 2, 1, 2, 2, 3, 1, 3, 2. Altogether, we have 6 outcomes, right? 6 outcomes. Understand? Now we are going to find probabilities of getting these pairs. Earlier, we found probability of getting number 1, getting number 2, or getting number 3 for different box A or box B. Now we are going to find the probability of getting these pairs. Okay, so here the pair is 1, 1. 1, 1 means 1 or 1, 1 or 1, or 1 and 1. What do you think? Probability of getting 1 or 1 or 1 and 1. 1 and 1. Okay, any other answers? Is it 1 or 1 or 1 and 1? What do you think? Yes, your answer is correct. That should be 1 and 1, not 1 or 1. Understand, this 1, 1 means 1 and 1, or 1 intersection 1. This one is different from this one. No, this one is what? Getting number 1 from box A. And the second one is what? Getting number 1 from box B. That's why we are writing it as 1 and 1. 1 and 1. Okay. So 1, 1 is 1 and 1. 1, 2 is 1 and 2. Likewise, we have 2 and 1, 2 and 2, 3 and 1, 3 and 2. We have 6 possible outcomes, or 6 pairs. So what is the probability of getting 1, 1? How can you find this probability? It is the probability. You need to multiply these these associated probabilities. 1, 3 times 1, sorry, 1 over 3 times 1 over 2. That is 1 over 6. Right? Here we have 1 over 3 times 1 over 2. Again, that's going to be 1 over 6. Clear? Here, 1 over 3 times 1 over 2. That's going to be 1 over 6. 1 over 6. 1 over 6. Again, 1 over 6. Right? for an particular event, that means outcome of the box A, if you consider that event, there are three possible outcomes now. So if you add these associated probabilities for the event of box A, that must be equal to 1, right? 1 over 3 plus 1 over 3 plus 1 over 3 is going to be 1. Therefore, we get 1 here, the probability. Don't put that 1 here, okay? So if you add this half and half, that is the outcome of box B. No? Half and half is going to be 1. If you consider this one also, this one, it also gives 1 over 2 plus 1 over 2, 1. Here also, the event of the next event from box B, right? Half plus half is going to be 1. If you add these probabilities for each and every outcome, again that's going to be 1 over 6 plus 1 over 6 plus 1 upon 6, 1 upon 6, 1 upon 6, 1 upon 6. Finally, you will get 1. Clear? Therefore, when you put these probabilities, associated probabilities, and these final probabilities, you have to be very careful. You have to get finally number 1, the total probability as 1. I already told you the total probability is always equal to 1. You cannot exceed number 1 for a probability value, right? The maximum one that you can get for a probability is 1. Okay, the probability is always in between 0 and 1. It can be either 0 or 1 or a number or a fraction in between those two numbers, 0 and 1. Clear? Therefore, when you put these probabilities, please be very careful, right? Okay, now we have finished, or we are done with constructing the tree diagram for this situation. Now we need to give answers. Okay, before answering the questions, you need to read those questions very carefully, and you need to understand what we are asked to answer. Okay, here part A, it says draw a tree diagram to list all the possible outcomes. Now we have done it. Okay, there's no worry. But when you answer part B, we have to find the probability that the sum of the numbers is 4. That means we need to find the sum for these pairs. No, the sum of the numbers is 4, the sum of the two numbers is even, and there are more questions about the product. Product of the two numbers is at least 5, and the sum is equal to the product. That means when we draw the tree diagram, it's not enough to, finish constructing the tree diagram up to this level. We need to consider their sums and products as well. Understand? Clear? Because questions are regarding the sum or product, right? Therefore, you have to consider their sums and products as well. So what is the sum of this this first pair, 1, 1? What is the sum of those two numbers? 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1, 3. 2 plus 2, 4. 3 plus 1, 4. 3 plus 2, 5. Likewise, we have 1, 2, 3, 4. 4 different numbers, 4 different values for sum. For the sum, right? Now create or construct their product column, right? What is the product of those two numbers in the first pair? 1 times 1. The product is 1. 1 times 2, the product is 2. 2 times 1, the product is 2. 2 times 2, 4. 3 times 1, 3. 3 times 2, 6. Likewise, we have 1, 2, 3, 4, 5 different values for products. Understand? So this is the final tree diagram for this problem, but remember you have to put associated probabilities as well. Without the probabilities, it is incomplete. So you have to complete the tree diagram first. Okay, according to the questions you need to answer. Sorry. Now tell me, what is the answer for the first part? Part B, Roman 1. The sum of the numbers is 2. What is the probability that the sum of the numbers is 4? The sum of the numbers is 4. What is that probability? The sum need to be 4. There are 2 pairs, no? 2, 2 and 3, 1. So how we are going to find that probability? Probability that the sum of the numbers is 4 is what? You need to add probabilities of these 2 pairs. 1 over 6 plus 1 over 6. Finally, you will have 2 over 6 or 1 over 3 as the probability that the sum of the numbers is 4. I will explain it to you. Give me a second. Yes, here. Now we have found these probabilities. The sum is 1, 2, 2, 4. Sorry. Product is 1, 2, 2, 4, 3, 6. Now we need to find probability that the sum of the 2 numbers is 4. So you need to select these 2 pairs. So what are the associated probabilities? 1 over 6 plus 1 over 6. That is 2 over 6. So you can represent that probability as 1 over 3. Understand? Is that clear? So this is the answer for first question, Roman 1. Okay, now see the second question. The sum of the 2 numbers is even. The probability that the sum of the 2 numbers is even. What are the even numbers from these numbers? 2, 4, 3 and 5 are odd numbers. Therefore, what is the probability that the sum of the 2 numbers is even? What is that probability? You need to select 1, 1 pair, 2, 2 pair, and 3, 1 pair. So 1 over 6 plus 1 over 6 plus 1 over 6, that's equal to 1 over 2, right? Because 1 over 6 times 3 is 3 over 6. Finally, it's going to be 1 over 2, right? Okay. These are the even numbers. Not even, odd numbers. Here we had 2, no? No one corrected it. Why? The sum is 2, no? 1 plus 1 is 2. 2, again 4, 4. The probability of getting the sum as 2 is 1 over 6 plus 1 over 6 plus 1 over 6. Right? The probability of getting the sum 2, 4 and 4. That's going to be 3 over 6. Finally, it is 1 over 2, half. Right? So this is really easy to solve. Okay, this is a very simple question. Now look at the next Question. The product of the two numbers is at least 5. The product of the two numbers is at least 5. Now, what do you mean by at least 5? At least 5. What does it mean? At least 5. If you are asked to find the probability that the product of the two numbers is 5, the product of the two numbers is 5, you cannot find any value because no one is equal to 5. No, the product, it can be either 1, 2, 3, 4, 6. If you are asked to find the probability that the product of the two numbers is 5, that is 0. Understand? But here you are asked the two numbers is at least 5. At least 5 means what? At least 5. The minimum number that you can get must be 5. The minimum number must be 5. Understand? The minimum number is 5. Okay, let me explain it. At least 5 now. At least 5 is least number must be 5 or the minimum number must be 5. That means you are asked to find the probability that the product of those two numbers is at least 5 means that number must be greater than or equal to 5. Understand? The minimum one should be 5. That means you are asked greater than or equal to 5. At least, aduma tarane paha. At least 5. The least number or the minimum number must be 5. That means probability of or probability that the product of those two numbers must be greater than or equal to 5. So we have only one value, no? That is 6. The product is 6. That is the only value greater than or equal to 5. Therefore, what is that probability? That should be 1/6. Understand? Did you understand, students? Therefore, answer for the part 3 must be 1/6. Or if you name that some product of those two numbers as x, here you are asked probability of x greater than or 5. Understand? So that is equal to 1/6. Understand? Or you can write it as probability x greater than or equal to 5. That is equal to probability of x when x is equal to 6. So that is equal to 1/6. But before that, you have to define the variable x. X is what? That's the event of product of two numbers, right? Product of two numbers. Did you understand that? Now come to the fourth part. It asks to find the sum is equal to the product. The sum is equal to the product. You can see that the sum is 2, product is 1, they are not equal. Sum is 3, product is 2, not equal. Here also not equal, but here sum is 4 and the product is also 4. They are same, no? Sum and product are same. Here, not same, not equal. 5 and 6 not equal. Therefore, only the pair 2, 2 satisfies that condition. Therefore, probability that the sum is equal to the product is 1/6 for the pair 2, 2. Understand? So that probability can be written as 1/6. Clear? Is that clear, guys? Before going to the next question, please, if you have any question regarding this example, please ask me now. Is that clear? Tell me. There are 48 students, including me. If you don't have any question, we can discuss the next example. Please tell me. Did you understand how to draw a tree diagram for this type of question or this type of situation? We have two boxes separately. Box A contains some number of cards and box B contains some number of cards. So we are taking one card from each box. One card from each box means we are taking two cards from two boxes. One card from one box. So if we have such a situation, we would draw the tree diagram for that problem like this. Okay, so the outcome of the box B does not depend on the outcome of box A. That is what you should understand here. But there are some situations where those probabilities or those events depend on the previous events. I will explain those things tomorrow in the next lecture. They are called conditional probabilities, right? We will discuss conditional probabilities tomorrow. Today we have to discuss only about tree diagrams, right? So when you draw tree diagrams, you need to identify independent events and dependent events separately. Okay, I will teach you later about independent and dependent probabilities. For now, please remember the outcome of box B does not depend on the outcome of box B. Okay, I hope you understood that problem. Now read the example number 2. Okay, read this. A bag contains 12 red balls, 5 blue balls, and 3 green balls, identical in all aspects except for their color. That means they are similar balls, only the color is different. They are identical in all aspects except for their color. Only the color is different. Okay, so bag that bag contains 12 red balls, 5 blue balls, 3 green balls. Altogether we have 20 balls. Okay, now 2 balls are taken at random. Now we are taking only 2 balls from that bag at random. We are taking those balls randomly. That means we are not looking at the bag. Without looking at the bag, we are taking 2 balls out. Now, can you draw a tree diagram to illustrate all the possible outcomes and associated probabilities? Can you draw? And you have to state your probabilities clearly as mentioned in the first question. Draw a tree diagram to illustrate all the possible outcomes and associated probabilities and state your probabilities clearly. Actually, this example was taken from your past paper. Okay, not your senior or super senior. Yes. Understand? So you will have in examination this type of questions. Now using the tree diagram, you have drawn, you have to answer the following questions. What is the probability that the two balls taken at random are same in color, and probability that the two balls taken are different in color? Small questions. You have two small questions to be answered. Before that, you have to draw a tree diagram. Can you draw a tree diagram to illustrate this situation or all the possible outcomes? Try to draw a tree diagram. While you are trying, I'm drawing the tree diagram. Okay. Now you have to draw. Here we do not have two bags. We have only one bag. But we are taking two balls. Okay. Understand the situation. Earlier problem in earlier one, we had two boxes separately. We were taking, or we took one card from each box. That means we took two cards from those two boxes. But here we have only one bag. We are taking two balls at once. Now, how can you draw that tree diagram? Can you draw a tree diagram for the situation taking two balls at once? Two balls? It's really difficult actually. Drawing a tree diagram, to illustrate those possible outcomes. Therefore, what we do is we have to consider taking two balls at once as taking two balls twice, not once. It's true, we are taking those two balls at once, but we have to consider that situation as taking two balls, taking one ball twice. I will show you how to draw a tree diagram for this problem. Give me a second. Now I forgot those counts. 12 red balls, 5 blue balls, and 3 green balls. No, 12 red, 5 blue, 3 green balls. Yes. Now we have only one bag. Now we are taking two balls. We cannot draw a tree diagram to illustrate those possible outcomes if we consider that taking two balls at once. Okay, it's really difficult. Therefore, we may think we are taking two balls, one ball twice. One ball twice means we are taking two balls, but separately. Let's say we are taking one ball first. Now, what is the what are the possible outcomes if we take only one ball? That ball may be either red, blue, or green. That is the outcome of, taking one ball one. Okay. Now tell me, what is the probability of getting a red color ball? Out of 20 balls, there are 12 red color balls. Okay, so the probability of getting red is 12 upon 20. Probability of getting blue is 5 upon 20, and probability of getting green color ball is 3 upon 20. Is that clear, guys? So this is the tree diagram when we select only one ball from that particular bag at random. Is that clear?
Yes, madam.
But this diagram, okay, but this diagram is not what we asked to draw. Okay, we are taking two balls now, but we have drawn this for taking one ball. Understand? Now I told you, you have to think this situation as taking one ball twice. Okay, let's say we have taken one ball once, right? Now we have taken one ball out. Now again we are taking another ball from the bag. Okay, in that case, when we take the second ball, where's the first ball? Is it out or in? Inside the bag or outside the bag? The first ball. If we take two balls once, okay, if we take two balls once, both balls are outside the bag. They all are out. Okay, but here we have drawn for the taking one ball out. Now I'm telling you, now the first ball is taken out. Now we keep that ball outside. We are not putting that ball into the bag again. Okay, keeping that ball out, we are taking another ball. What are the possible outcomes? Now we are taking another ball, keeping the first ball out. We are not putting that ball again to the bag. So what are the possible outcomes? Again, there are three possible outcomes. It can be either R, B, or G. That outcome does not depend on the outcome of the first ball. Okay, that does not depend on the first one. Therefore, we may get either R, blue, or green. Here also R, blue, or green. Here also R, blue, or green. Understand? But here it's really important to put these probabilities correctly. Okay, now we are going to find the probabilities of the second outcome or the outcomes of the second experiment, that is taking the second ball out. Okay, now tell me, what is the probability of getting a red ball as the second one? Now tell me, how many balls are there in the bag? Now earlier it was 20. 20 balls were there and we took one ball out. Now how many balls are there? Okay, I got one answer from you. 1/11. It is 1/11. Oh, no. You are very closer to answer, but that is not the correct answer. 19. Yes, there are 19 balls are in the bag because we have taken one ball out. Only 19 balls. Now, out of 19 balls, how many red balls are there? Now tell me. Now it's clear. We have only 19 balls inside the bag, in the bag, right? Now tell me, how many red balls are there?
11.
Yes, very good. That is 11. That is 11. Why? We have taken red ball out now first as the first ball. That means now we have only 11 red balls, not 12. I got another answer from you, 11. Yes, very good. That means we have 11 red balls in the bag out of 19. So the probability of getting a red color ball as the second ball is 11.19. So what is the probability of getting blue? 5/19. Getting green, 3/19. So if you add these three probabilities, that should be equal to 1. 11 plus 5, that is 16. 16 plus 3 is 19. Yes, 19/19 is 1 now. That means we have found these probabilities, associated probabilities correctly. Understand? Now, can you fill the other probabilities as well? What is the probability of getting a red color ball as the second ball? Still, we have 19 balls because one ball is out, but that ball is a blue color one.
12.
12. Yes, very good. We have 12 red balls because first ball is a blue color one. We have taken blue color one. Therefore, we have remaining red color balls are 12. How many blue balls are there?
4.
4.
Very good. 4 blue balls out of 19. Green color, 3. If you add these 3 probabilities, 12 plus 4, 16. 16 plus 3 is 19. 19 over 19 is 1. That means they are correct. Now come to the next branch, that is taking the second ball. Okay, we have 3 possible outcomes. Can be either R, B or G. The probability of getting red color one is 12 upon 19. Probability of getting a blue color one is 5 upon 19. Now tell me the probability of getting a green color ball. How many green color balls are there in the bag now?
2.
2.
Yes, there are only 2 balls out of 19. So if you add these 3 probabilities, 12 plus 5 is 17, 17 plus 2 is 19, 19 over 19 is 1. That means we have put these associated probabilities correctly in the tree diagram. So we have, actually we are done in constructing the tree diagram. Now we need to list all the possible outcomes. These are the outcomes for selecting one ball and second ball, but we finally had to write the final outcome, right? So what are the final outcomes of this experiment? If you consider this branch R, R, that means R and R. That means the first ball is R and the second ball is again R, R and R. Then R and B. The first ball is R and the second ball is again blue. R, G. B, R, B, 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 G. Finally, we have G and R, G and B, G and G. Understand? So if you want to find the probabilities of these events or these outcomes, you have to multiply these associated probabilities. 12 upon 20 times 11 upon 19, that is the probability of getting R and R. Clear? Likewise, you can get all the probabilities. Okay, 12 upon 20 times 5 upon 19, that is 60 over 380. 12 over 20 times 3 over 19, that is equal to 36 over 380. If you want, you can simplify these probabilities, okay? You can simplify them further. Anyway, you have to write all the probabilities for each and every outcome. Now, let's look at the questions we have to answer. First one, draw a tree diagram to illustrate all the possible outcomes and associated probabilities and state your probabilities clearly. Now we have done it. We have stated all the probabilities and associated probabilities in the tree diagram. Okay, so we have done part 1. Now see the second question, part 2. What is the probability that the two balls taken are same in color? That means we have taken two balls. We have to find the probability that those two balls are same in color. Their color should be same. Now we have to pick the pairs which satisfies this condition. Understand? The color should be same. It can be either R and R. Here we have R and blue. No, we cannot pick this. R and G, no. B and R, no. B and B, yes. They are same in color. Then G and G. That means we need to add the probabilities of R and R, B and B, and G and G. Understand? So here the probabilities getting B and B is 5 upon 20 times 4 upon 19. That is 20 over 380. Here the probability is 3 upon 20 times 12 upon 19. That is 6 over 380. So the answer for the second is this probability, this and this. You need to add these three probabilities. 132 over 380 plus 20 over 380 plus 6 over 380. Finally, you will get 142, 52 plus 6, 58. You can simplify this, okay? The answer. Is that clear, guys? Guys, is that clear? Yes or no?
Yes, madam.
Okay. The probability that the two balls taken are same in color is 158 over 380. Again, we have another question. What is the probability that the two balls are taken are different in color? There we have to find the pairs, okay, in which the colors of those balls are different, right? So how can we find that probability? There are two methods to find this probability. How we are going to find that? Tell me. The probability that the two balls taken are different in color. Either you can add probabilities of these outcomes. These two, this one, this one, this one, this one. The colors are different. You can add those probabilities, or there's another method. What is that? There's a simple method. You don't need to add those probabilities to get that. Finally, you will have the same answer. But the easiest way is, if the total probability is equal to 1, I told you, always the total probability is equal to 1, right? The probability of getting same color balls is 158 over 380. The probability of getting different color balls should be 1 minus 158 over 380. Understand? Find this value. Is that correct? Understand? So if you add these probabilities, getting R and B, R and G, B and R, B and G, G and R, G and B, you will get the same answer as 222 divided by 380. Understand? Therefore, in the examination, when you answer those questions, you need to save your time, because within 3 hours, you have to answer 6 questions. So it's better to use the second method, that is the method of subtracting the probability of getting same color balls from the total probability. Understand, students? Yes or no? Yes or no?
Yes,
But you have to be careful in calculation, right? I don't know whether these numbers are correct. Anyway, this is the method that you have to use. I hope you understood how to construct tree diagrams when you have this type of situation. Earlier, we had 2 boxes and each card is taken from one bag or one box. So in that situation, we have to consider taking one card from one box separately, right? But here we are taking 2 balls. Here we have to consider taking 2 balls as taking one ball once and taking another ball again. Okay. Therefore, we call this type of problems as without replacement problems. Without replacement problems means, okay, if I now the time is 12:04. I want another few minutes, only 2 minutes, right? I'm taking only 2 minutes from you. Sorry for that. In this problem, we are taking 2 balls. Okay, but when we draw the tree diagram, we consider taking 1 ball first and taking second ball again. Next. In that case, we call this type of case as with replacement case. Sorry, without replacement case, because the first ball that we took out is not being put into the bag again. We keep that means we keep the first ball out when we take the second ball. Understand? So this situation is similar to okay, taking one ball first and record the color. And we do not put this ball, okay, we do not put this ball again to the bag. Without putting back, we are taking the second ball, another ball from the bag, and record the color. Understand? So we call this as without replacement. Without replacement, we do not put the first ball again to the bag without replacement. So you can consider this situation as without replacement case. Understand? So this is like we are taking one ball out and record the color, and we do not put that ball again to the bag, and again we are taking another ball and record the color. Understand? But there are some cases like we are taking one ball out and record the color, and we are putting back that ball into the bag. Again, we are taking another ball, second ball. In that case, when you draw the tree diagram, the possible outcomes are same. Only the associated probabilities will be changed. Okay. So these type of problems are called with replacement. First, we take a ball out, record the color, and we put that ball back into the bag, and again we take a ball. So if you want to draw a tree diagram for this situation, let's say we have 3 balls like previous example, like this, 12/20, 5/20, 3/20. So you are taking another ball from that bag. The possible outcomes are similar, right? RBG, RBG, RBG. Associated probabilities, be very careful. In that case, we have put the first ball into the bag. No. In that case, we have still 20 balls. Out of 20 balls, still we have 12 red balls. Because we have put the first ball into the bag. Understand? So likewise, you can get other probabilities as well. Anyway, what you need to understand is this type of case is called with replacement. If the first ball that we taken out is being putting back to the bag. But here, without replacement case, we do not put the first ball to the bag again. We keep that ball outside. So if you have this type of situation, taking two balls at random, you have to think that situation as without replacement case. Understand? Yes or no? Anyway, so we have another example to discuss with you in the slide presentation. We will discuss this example tomorrow, and let's start conditional probability from this example number 3. Okay, and ask your friends to come for the next lecture, because as I believe the conditional probability is the most, important and difficult part in probability. All the other sections are really easy to understand, and conditional probability is, I'm not saying that is difficult, but it's not easy. Therefore, ask others to come to the lecture tomorrow. Tomorrow we will be discussing conditional probability, how to find conditional probabilities from tree diagrams and by listing all the possible outcomes. Okay, so it's really important for you to come for the next lecture. Okay, if you don't have any question regarding today's lecture, I can stop the lecture for today. So do you have any questions? Yes or no? I know you all are at your home now. We need to discuss some tutorials as well. I just prepared tutorial 1 for you, but it's not finalized. I have to send those tutorials to Shelton sir. These days we are a little bit busy with conducting lectures and paper marking. Therefore, I couldn't send it to the Shelton sir. Once I get the tutorial from Shelton sir, I will upload that to the LMS. Anyway, you will be given 1 week to submit your answers to the tutorials. Okay. Okay. So if you don't have any question, I'm going to wind up the lecture for today. Thank you for joining the lecture. Thank you. Have a nice day.
Thank you, madam.
Thank you, madam. Thank you, madam.
Thank you, madam.